Hey, I wanted to make this quick video for you. It's a really interesting thing that I kind of figured out. Not that I figured it out. I mean, it's obvious, but once you have to look at it for you to be able to see it, right? So this is a light simulator, and I've drawn an arc down here, and I've drawn a ball up here, and then this is the light source, and I can move the things around. So I can move the light source around, and I can make the arcs different shapes and sizes and all kinds of stuff like that. I can make them reflective and like just cool stuff, right? So what I have here is a light source. I have a ball, and then I have a reflection onto a much bigger ball. And what you'll notice is that when you take the small one and you move it closer, the shadow gets smaller until it's about to get to be the same size in general as the edges of the ball, right? And if I take the point light source and I move it farther away, you can see that that shadow is not getting any smaller, right? It's actually fading is what it's doing. And when I move the ball farther away, the shadow gets much wider and bigger. Okay, so I want you to think about that while I'm showing you this other piece, okay? Because what I'm showing is an eclipse, essentially, right? So what I've drawn down here is I've drawn to scale the Earth and Moon. Okay, so I have this is the Earth here, and this is the Moon here, and I've used this engineer scale to do this, and the Earth is one of these units. This is at a 40 scale, for example. And obviously it's not a perfect circle, but you'll get the idea. Now 30 Earth diameters away, see, so it goes from 30 to 31. 30 Earth diameters away, you have the Moon way over here. Now, at this scale, and this is on a sheet of paper, you can see this is the 11 side of a sheet of paper, the long side. I have the paper turned landscape. How far away is the sun, and how big is it, is the question, right? And what you find is, like, let's say you put this at the touchdown line. Okay, so this is the end zone, this is the touchdown line, and then this is like headed towards the 1 yard line over this way. How far away is the sun, and how big is it? Is it at the 20 yard line, the 50 yard line? Like, whereabouts is it? Okay, and the answer is that it's at about the 75 yard line, and it's about 2.5 feet around. So it's about as big as an exercise ball, right? So that gives you an idea of the scale at which we're looking at. So now what I've had to do is I've had to draw this in such a way that that we negate some of those size scales, basically. So this is not drawn to scale for distance, just like every other eclipse drawing is, right? It's not drawn to scale. Now the question is how big around is the Earth, and how big around is the Moon? Okay, and what you find is that the Earth is it's a little smaller than 7,900 miles in diameter. Okay, so from here to here. Okay, a straight line through the center. And then the Moon is, I think it's a little bit under, it's ballpark, okay? I just rounded just a little bit for simplicity. 2160. The rounding, you'll find, isn't going to matter when we get down to what I'm about to show you. But if the sun is over this way, and it's casting a shadow on the Earth, kind of like this is doing, all right, this is what they tell you it does. They tell you that the sun ray comes in off the bottom and casts a shadow this way, and the sun ray comes off the bottom here. Let's see if I can do this, and cast this little tiny shadow here like this, and actually it's much smaller than that. The eclipse, that the solar eclipse that we have just seen, what was it, last year, the year before, was 70 miles of a circle. Okay, 70 miles in diameter. Okay, so I've drawn it significantly larger than this, because I mean we're looking at, if it's 70 miles, we're looking at maybe 100 of them fit on the Earth. So really, it's like a point. It's like very, very tiny. Okay, but I've drawn the shadow here. It's much, much smaller. In fact, let me see if I can do a better job and maybe just draw a little tiny circle like this. And that's what they're telling you the eclipse is, and the way that they're saying it is with the umbra and the preumbra and all this stuff, right? Um, okay, so if that's the logic, and if that's how that happens, okay, and it comes across this way, then the same thing should happen if the sun is over here and we're doing a lunar eclipse. So the ray of light should come in just like they say. And how big is it? Well, what they tell you is that it is the same size as the moon, like this, right? And they say because of the distance and all this different stuff, right? Okay, but what you find is something that's very interesting. Okay, so if you take the diameter of the shadow, right, and you take the diameter of the moon, okay, and you divide the shadow into the out of, I don't know how it goes, but if you take 70 and divide it by 2160, what you get is 0.03. Where is it? There it is, 0.03241. Okay, and then if you multiply that number, okay, by the diameter of the Earth, maybe, so now we're taking this ratio that we've created, 70 over 2160, and then we're going to say, okay, well, what's the ratio of the shadow going back this way? What you end up finding is that it gives you 256 miles. So you take the 7,900, you multiply it by the decimal that we created, and we get 256, right? 256 miles. So 256 miles on this moon here is a little bit over 10% of the diameter. So instead of seeing a full blackout of the moon, what we should be seeing is something more along the lines of this. So we should see the moon as 2160, and we should see the shadow of this Earth at 256. And we don't see it that way, obviously. It's very, very different. They say that it covers up the entire face of the moon. But with the same math and the same logic, it doesn't work that way. So how does that happen? So it works in one direction, one way, and it works in another direction a completely different way. It makes absolutely no sense. And you can see that if you have a light source and you pull the ball closer, the shadow gets smaller. But as you pull the ball farther away, the shadow gets bigger. So, such that the moon shadow should probably cover a massive amount of the Earth. If it's this distance away, it should cast a very large shadow. And the same if the sun is over on this side and the sun is blocking out the moon, it should just cover up the whole thing entirely, kind of like it does, but it should be much bigger than what it is. It should be like massive. So I hope you enjoyed the video. I hope it raises some questions, and let's start a conversation here. I'll talk to you soon.